So some of that new stuff we're to get in today is we can discuss whether that number all the way to the right is an outlier, and we could debate it, but there is a way to math it. Then it's less of a debate, okay? Then the debate only becomes, should we keep it or should we eat it, okay? But first we need to know, actually, is it an outlier? So this is down here in the text. We're just going to kind of roll through. Really is 1.5 times the interquartile range, more than the third quartile. Does it fall within that? And I know that just sounds like a lot of words. So let's look at what that means in terms of the math and the numbers. So first we're going to look at interquartile range, which is about 3. We all on board with that IQR being about 3? I'm just looking for some head nods. Yeah. I did third quartile minus first quartile. It's about 3. Okay. So this new rule that we're establishing to see whether something is an outlier would have us take that third quartile, right, which is 5, and we're going to add on 1.5 times the IQR to that. So it's the 1.5 rule. 1.5 times the interquartile range on top of the third quartile will tell us if something is an outlier or not. So that gives us 9.5. And what that means is if there's anything above 9.5, that number is an outlier. Well, do I have a number above 9.5? Well, 9.5 is right here, and that shows a max above it. So the math here by quartile says, yes, outlier. Barely, but it is. Okay? Now, this isn't on here, but let's look at the lower level. It looks closer to the middle, doesn't it, the lower? But let's see what the math does. The first quartile is 2, and I'm going to subtract 1.5 times 3. And I get negative stuff. So can there be a negative price per person for healthcare? No. So is there even an opportunity for a low outlier? No. So again, this is the rule of 1.5. The rule of 1.5. So this is another visual about that 1.5 interquartile range. So this doesn't have all the numbers on it, and sometimes you'll just have a list of data. It won't always be in a box and whisker. So again, we're going to look at the IQR. Oh, I wasn't on my writing part. All right. Our IQR is 13 minus 9, or 4. You all on board with that? Yeah. Okay. So to see my upper bound here, I'm going to go with my third quartile, which is 13, and I'm going to add my 1.5 rule to my IQR, which gives me 19. This means I don't know exactly what they are because I don't know my raw data, but anything in that section there is an outlier. Okay? On the lower end, my lower quartile is 9. I'm going to subtract 1.5 times 4. 4 is my interquartile range, and that gives me 3. So anything outside of that, where I circled right there, anything that falls in that range would also be an outlier. The 1.5 rule. 1.5 times interquartile range. We would add it onto the third quartile. We would subtract it from the first. And we're going to practice it still. Don't worry. There's that same visual we saw. So here's where you're going to get a little practice, okay? This is the actual data, the raw data for the per capita price of healthcare in countries, okay? And you're going to use decimals in a moment. Don't go yet. You're going to find the mean standard deviation in the 5-number summary. Reminder, what do you type in for 5-number summary? Stats. What do you type in for standard deviation? STDEVP. Okay? And the mean is pretty standard. Now there is a maximum here, and we calculated like close, right? We use like whole numbers and stuff. You need to determine whether this is an outlier and how you know. And then we're going to, in a second, we're going to look at what happens when we mess with the outlier. But first of all, find the middle. Find how close we are to the middle. Find out if it's an outlier. What are you going to have to find from the 5-number the 5-number summary to determine the outlier? What's something that you got to pull from that? IQR. Okay? And I wrote, you can see on the board over there. I guess I'll write it on here too. You guys see on the right side of the board? Yep, IQR times 1.5. Okay, so you're going to do third quartile plus that to get your upper bound. You're going to do first quartile minus that to get your lower bound. And see where it says use this link? You can copy and paste from the quote-unquote textbook instead of typing it all in that way. All right, let's get after it. So let's look at the data that we got from Desmos. The first thing I want to find is the IQR. And I'm doing that by doing the third quartile, so 4.8398, minus the first quartile. So what's the range inside my quartiles? That's 2.1495. And I got an IQR of, I got to get this calculator going, 2.1495. 2.6903. So that's my IQR. Everybody good?
Yeah, we do.
Okay, this doesn't tell me what my outlier is, though. To get my outlier, remember, I'm trying to see if this guy right here, 9.8923, is an outlier. And to do that, I'm going to go to my third quartile, and I'm going to extend it by 1.5 times my IQR. So I'm going to add 1.5 times of my IQR onto that. And that gives me the value. I don't think that's right what I got. 4.8398 plus 1.5 times 2.6903. Yes. 8.87525. So if it falls within that range, higher than my third quartile, then not an outlier. But 9.8923 is bigger than that. So guess what? It is an outlier. Okay? Again, the reason it's an outlier is because I took my third quartile, I added 1.5 times my interquartile range, and it is above that value that pumped out. In a minute, we're going to discuss whether we should keep outliers or not, depending on situations. What you're going to do right now is I'm going to keep this data up, and you're going to take the outlier out of your Desmos, and I want you to keep track or compare how the mean, the median, the IQR, the standard deviation, how that all changes. So you're going to remove your outlier from your data and compare it to my data. I'll clean up this page a little bit so you can see it better. So you're going to compare it without the liar, what happens to the mean, the median, the IQR, standard deviation. Okay? So I'm going to need you guys, I can't look at two at the same time. So what is the new mean once we get rid of the outlier? Who can read that off to me from yours? All right, James?
The mean?
Yeah, the new mean.
3.53908848.
Yeah, that's good. That's good. Thanks. Who can read the new median? Ben?
3.391.
So which one changed more? The mean or the median? The median changed by 0.1. The mean changed by 0.21. The mean changed by more. Just something I'm pointing out. And then my interquartile range, it used to be like, now it's like 3.7. What was it last time? Or no, it was like, not 3.7. I looked at the wrong numbers. It was like 1.7. Okay. What is it now? The IQR. That's not 1.7, still 2.7. What's the new IQR? 2.6-ish. So again, because the median didn't change much, the IQR won't change much because it's a measure of center around the median. All right, and then standard deviation, what happened to that one? Someone over here. Standard. What's my new standard deviation when we eliminate? Greta? Which doesn't seem like a big change, but 0.3 out of 18 is like a sixth less. So this also changed big. Well, standard deviation references the mean. So just like we already know, outliers are skewed. Which number do they mess with more for center? Mean or median? Mean. And if it messes with the mean more, the measure of variability, according to the mean, MAD and standard deviation also gets messed with more. That's just a big idea I want you to have. Okay? All right, let's get back. We're going to look at crime in college next. Yeah, no. We already talked about all those things. So, right here, our data here shows the number of crimes that happen at colleges in California. I don't know how, I think there's one, two. Anyway, there's a lot of them there, a lot of pieces of data. You have all of your number summary that you need right here. I want you to decide if there are any outliers and how you know. And then why do you think there are outliers? Like what's happening situationally that's making the outlier happen? All right, so without giving you too much, what's the first thing you're going to need to find to try to help determine outliers? Yeah, IQR. And then I have the help on the side of the board for you still for the 1.5 rule. Let's take a look at how to do this. My IQR is Q3. Mine is Q1 for 208. Thumbs up if we're all good for finding the interquartile range. That means half my data is up in here. Now, big picture, kind of what I'm doing is I am extending this range to see if the data that's bigger and smaller fits within the extended range, right? So I'm going to take my, it looks like I'm not worried about little numbers. I'm only going to look on the high end. I'm going to take my third quartile, 260, and I'm going to add 1.5 times my IQR to it. So I'm extending it. 260 plus, should I do this in my head? 312? Yeah, 572.
Yeah, that's right.
So anything that's more than that by math, by the 1.5 rule, is an outlier. So that means these three data points that I just circled are all outliers. Here's why there's no lower outlier. 52 minus 1.5 times 208 is going to be some negative junk. And you can't have negative crime. Like, I was like, well, maybe if Mr. Beast goes and just gives money to people, is that negative crime? Probably not, actually. That's as close as I could get. So, no negative crime. So there's not even a possible low outlier, only the high outlier. Okay? Now, again, interquartile range is right here. Times 1.5. I extend it from my third quartile. Anything that is out of that range is going to be an outlier. So these three right here. Now, kind of just for fun, not just for fun, we need to decide if we should keep our outliers. Keep it or yeet it, all right?
Yeet it.
Now, we need to decide what's the reason. Why do we think there's such a range in crimes in colleges in California? What's a reason that might happen? What is that? There are a lot of people, but are there a lot of people at all the colleges, Mari?
Oh, that's not what I was going to
Oh, what were you going to say?
That they didn't get caught the first time.
Oh, some places they are more bold, so they got caught multiple times or something? Okay, why might there be more crime at certain colleges? Ben? Georgia?
Oh, nice.
Oh, if they're in good neighborhoods or not? Or expensive college versus cheap college, maybe? Could have? Okay. There's one big one here, I think, that we're missing. I'll tell you this. We looked it up in Michigan earlier today. Michigan State has the most. Michigan State's the largest school in the state. Second most was Michigan. Michigan's the second largest school in the state. Third was Wayne State. Third's the third largest college in the state. Ben Hannah, how big the college is, right? Some teeny little college. Oh, I asked Rylan. Okay. The amount of people, yeah. So the one thing I would say is these are probably valid numbers. I don't think I'd eat them. But if we're worried about them skewing our data, what could we use for a measure of center instead of the mean? The median, right? Also, is there a way we could make it work for all the colleges in crime? Like, is there a way we could take how many people go to the college out as a factor somehow?
Yeah. No. I don't know.
I think there's a way to math it. Well, if there's 10 people and one person's naughty, I know 10% of people are naughty. If there's 100 people and 10 people are naughty, I know 10% of people are naughty. So what am I getting at? No. How could we take size out of the equation? Yeah, by how you can substitute how many people you are. We could find like something like a ratio of crime to people, right? And then it's a percentage or a ratio. That would mean it doesn't matter the size. That could be a way. So, keep it or yeet it is what we're looking at now. There's a number cube, 1 through 6, and they roll all these times. Someone got a 20. Let's vote. Raise your hand to keep the 20. Raise your hand to yeet the 20. Yeah, you can't get 20 on a 1 through 6, so obviously bad data, right? Okay, here's a dot plot. And this is how many siblings. There was a 12. Let's raise your hand to keep it. Raise your hand to yeet it. Okay, so I would say, while 12 does not seem typical, I would just make sure, if it's an accurate piece of data, let's keep it. It's a real. But if it was a mistake, maybe someone didn't understand the question, yeet it and rewrite it. Okay, do you guys see it? So if we're worried about it skewing our data, what do we use instead of mean then? Median. We have math to fix that. So, but if someone legit had 12, that's a real piece of data. We should keep it. A science class, 11 people made biodiesel and measured the mass, but one of them was a 0. Keep it or yeet it. Raise your hand for keep it. Raise your hand for yeet it. Yeah, if only one group had nothing work, what's most likely to have happened? They did it wrong, or they mismeasured, right? So they measure again, try it again, something like that. Yep, let's yeet that one. So, we kind of already talked about all those things. Here is your lesson summary. What I want you to do, there's like almost nothing to do. I want you to make sure that you can get that 1.5 times EQR to get you this value here, okay? So make sure you do your 1.5 times IQR to make sure that works out to match up with your box plot there.